Let's solve LeetCode 347 top k frequent elements. So given an integer array nums and an integer k, we want to return the k most frequent elements. We may return the answer in any order. So let's say an input of nums is equal to 3 ones, 2 twos, and 1 3 is given. And k is equal to 2. So what we want to do here is we want to return top 2 most frequent elements. So the output is going to be 1 and 2. Why? That's because 1 exists 3 times, so that's the most frequent element. Then 2 exists 2 times, that's the second most frequent element, and we want to return top 2 frequent elements. Over here, nums is equal to 1, k is equal to 1, the output is 1. And that's because, well, top 1 element and there's only 1 element in the array. And then finally this one, the same thing goes. I'll not go over this. This is a bigger one, but you get the point. So we want to return the top 2 most frequent elements. Now, usually when we get top k frequent elements, our first instinct would be to go over something like heaps. But this is from the LeetCode roadmap. It's present in arrays and hashing. We're going to solve it using arrays and hashing, and the time complexity for it is going to be O of n. If you use heaps in this particular equation, you'll get O of n log n. And yeah, we don't want that. The reason it will be O of n log n is because what you'll try to do is go over this entire array. For every element, we'll push it into a heap. And then once we do that, we can just try to heap pop. And well, that already makes it O of n log n, because for every element that we do, we are doing a heap push or a heap pop. And heap push or a heap pop by itself is O of log n. And when you go over this array and do heap push or heap log, it will be O of n going over this entire array into O of log n, which is pushing or popping. So we're not going to take the heap approach over here. We're going to take a arrays and hashing approach. And that should be quite easy to understand, because I'll just copy this and draw it out. The reason I say this is because if you remember, when I was interpreting the question, I said, how many times does 1 exist? 1 exists 3 times. 2 exists 2 times. 3 exists 1 time. What was I doing? I was creating a mapping here that the number we have maps to how many times the number exists, the frequency of that number. So we have the mapping created. And now you might say that we can just return the numbers or the keys that are present over here. So if k is equal to 2 in this instance, we can just take the keys of this map and return top 2. And well, it would be right in this particular scenario, but in a scenario where it's not already sorted, it would give an error, or it would cause the test cases to fail. The reason for that is over here, we got lucky. Everything is sorted. But what if we have an array which is something like this: 2, 1, 1, 1, 3, 3. So here what we have is a mapping which is 2 exists 1 time, 1 exists 3 times, and 3 exists 2 times. If we do that, then, we try to return the keys from here, and then we return top 2, which is 2 and 1, which is the wrong answer. The answer should actually be 1 and 3. That's why we can't do this. What we'll have to do instead is sort out this entire map. So we sort it according to the values that are present here. And once we use this sorted function, we have entered the arena of, again, O of n log n. And that's what we're trying to avoid here, when we don't want this particular approach. So what can we do instead? Let's figure it out. At least a mapping part is correct as of now. We just need to decide how do we lay out this mapping to get the top most frequent elements. Let's think of it this way. What if I had an array which automatically placed the elements that are present here according to their index, and then I go reverse from here. So what I'm trying to do is, let's say 1 exists 3 times. So what I'll do is at index 0, 1, 2, 3, I'll go and place a 1. then 2 exists 2 times. So I'll just go and place 2 in the second index. 3 exists 1 time. I'll go and place 3. And after that, I'll just go reverse on this array. I won't start from the beginning. I'll start from the end. And as long as k is not satisfied, I'll just push elements into my result array. And that will be the top 2 frequent elements. So in this case, what will happen is that I start from here, 3 is present. So like I go to index 3, 1 is present over there. So I push out 1. Then I go over here, 2 is present. So I push out 2. And then I go over here, 3 is present. So I push out 3. Well, by the time we reach 3, it will not actually be in the array. That's because k is equal to 2. We'll only go as long as k is not equal to 2. So as long as this length of array is not equal to this k, we'll keep going and then we'll get our answer, right? Let's try it out for another one. Let's say our array was actually a different one. Let's take a more complex example as a result. Let's take this one. And then I'll just use a text. Then I'll just enlarge it and let's see. So here's our mapping. So we have 1 exists 1 time initially, but we know in the future it's going to come, so I'm not going to write it. Then we have 2. 2 exists again multiple times. Now let's calculate 1. 1, 2, 3, 4. 1 exists 4 times. 2 is 1, 2, 3, 4. 2 also exists 4 times. And then we have 3, which exists 2 times. And in this case, what are we trying to return? We're trying to return k is equal to 2. So how do we return and what do we return? According to our logic, we are just going to lay out an array at index 4. We are going to push out 1. But then we see that at index 4, we also have an additional element, which is 2. And that is something we need to figure out. Instead of this being a list that only carries integers, what we are going to have is a list. So this main list, which contains another list, which contains an integer. So here we are going to have a space for another array. And everything within this is going to be an array because there can be multiple elements with the same frequency. 1 can occur 4 times, 2 can also occur 4 times. That's what we're trying to solve. And once we do that, once we have all of this in place, 3 can go at index 2. So this is index 3, this is index 2, 3 goes over here. Then we go here. We also have a result array. And then what we do is, as long as this length of array does not match this array, the length of k, sorry, not this array. So as long as this result array does not match the length of k, we are just going to keep going in the reverse direction. So I push out 2, I push out 1, and then I reach k. So I'll just return. This is our answer. And indeed, 1, 2 is our answer. Now I return 2, 1. But we are returning 1, 2 from here, and that's fine because we may return the answer in any order. So that's good. Another thing to keep in mind is some edge cases. One edge case is that what if we have only one element in nums and k is equal to 2? What would happen in that case? Well, we are luckily given a situation where k is in the range of 1 to the number of unique elements in the array. So this guarantees that k will never exceed the number of unique elements, right? So this is always going to be 1, or let's say the number of elements here was 2. So it would be 2, but it would never be more than the length of nums because k is in the range of the number of unique elements in the array. So yeah, that's one edge case. And another one was that it is guaranteed that the answer is unique. The answer will be unique. Don't worry about that. So those were the two things. Now let's get started. What we want to do is first create a mapping. So I'll just create a variable called mapping, which is equal to an empty dictionary. After that, I'll go over all of the elements in nums. And then what I'll do is mapping at num plus equals 1. Now, if I want to do plus equals 1 on this map, what I need to do is create a default dict that comes from the collections library, standard library of Python. That's because, well, I don't want to do if num not in mapping, then we'll do mapping at num is equal to 0, and then we'll do mapping num plus equals 1. If I did this, I could just have a dictionary like this. But now I'm just doing a simpler version, saves me a lot of time. So yeah, after this, what we can do is we have a mapping. Once we have a mapping, we just want to lay it out in an array. How do we lay it out in an array? What I'll do for that is create a result variable, which is going to be a list, and it's going to be a list of how many elements. So we're just going to have for I in range length of nums plus 1. What have I done here? I've created an empty list, which is going from 0 to the length of nums, including length of nums. Plus 1 will be omitted because, well, we are in Python. The last number doesn't count. So we are creating over here an array, which is of the length of the numbers that are present. Cool. Why are we doing that? Because we want to access their index, right? And also I'll explain the plus 1. Let me just clean off the plate and then I can probably explain much better. So let's go and delete this. Cool. So what am I talking about? I want to create an array which has multiple arrays within it. Now, how many arrays do I want? And I have to pre-tell how many arrays are going to be present because I'll be accessing them by index. So if I don't initialize, it's going to be an empty list. And if it's an empty list, how can I say at index 0, I want to append an element, or if I want to remove an element? I can't say that. That's why I'm creating a list which is empty over here. Now, how many of these do I need? Well, we know that the Python list will go from 0 till the number of, elements, till length of nums. It won't include plus 1. So let's say length of nums was 5. It will create elements from 0 to 5, including 5. So it would be 0, 1, 2, 3, 4, 5. We don't want 6. So it won't include 6. So what we are trying to do here is, let's say we had how many elements here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are creating an indexing from 0, 1, 2 until 10. Okay. Now what we'll do after that is that, let's say at index 4, I'll just go to index 4, and at index 4, I'm just going to add an element of 1. Then at index 4 again, I'll add another element of 2. And at index 3, it will be 2. Now the reason I'm going till 10 and not the max element over here is because that would be an O of n case. I don't want to optimize for memory. I want to optimize for time. But you can ask your interviewer whatever you want, if they want to optimize for time or for memory. If it's for memory, then you can just do max of this particular map. But in my case, I'll just do 10, 11 elements, how many ever elements are present. Cool. As I mentioned, again, it could be just max of the mapping. And then you also have to mention what part of the mapping you have to look at. So max of the mapping dot values is what you're probably looking for. So either ways, you'll have to figure that out on your own. It will be a more complex equation, but yeah. After that, as I mentioned, I want to go over each element of this map and just put it in their places. So what I'll do is for, let's say key and value in the mapping dot items, I'll just do result at value. Remember, I'm doing result at value because what I want to do is go at index 4. This is the result array, by the way. So I'll do result at 4 and append that element to it. So I have result at value dot append, and then I'll append the key. With this entire for loop, I'll have my nice array created. coming back to the simpler example, we'll have something like this. So this is index 0, index 1, index 2, and index 3. And there'll be a lot more actually, because there are 6 elements, and I've only done 4 till now. So yeah, you'll have to do 3 more, but I won't do that. It's a lot of waste of time. But yeah, what we've done here is that, let's say we have 1 year, 1 or 2 year, and 3 year. That's what we've tried to accomplish. Result at value dot append key. After that, what we want to do is go reverse on this array. And after going reverse, I want to find out and push all of the elements in the result array. So I'll just create a result is equal to this. And actually we've already created result. I'll call this final. So this is the final array that we are going to return. And then what I'll do is go reverse on the result array. So I'll do for, let's say, I in range length of result. And I just can't do length of result because result is in the range of max of nums plus 1. I can't do plus 1. I have to do minus 1 over here, because what I'm doing here is going from the end to the beginning. And this is how you go from end to the beginning. So this is the starting value. Starting value is always including. The ending value is not included. That's why we are doing here plus 1. Plus 1 is not included then. Here minus 1 will be included. 0 will not be included. And we go reverse. That's why we have specified negative sign. Essentially, you just need to understand that we are going from the end of the array to the beginning of the array in the reverse direction, like this. Okay. This is just some syntax things that we're doing. And now what we'll do is just check that, hey, if k is equal to the length of the final array, then we just want to break out. The reason we want to break out is we have got the top 2 most frequent elements. Let's just break out. And once we break out, we are just going to return the final. But even before that, we need to populate the final element. And for that, we'll just have to put something. So here what we'll do is, for every element that we go through in this result array, we'll do final dot append element. And this way we are done. What have I done here? So we are going from the end to the beginning, correct? So let's say I start from index 6. It is an empty array. Index 5 is also an empty array. Index 4 is also an empty array. So these 3 essentially give us nothing. Then we start from index 3. We have a final array. And what we've done is, for the I in range from this to this. So I now contains the value 3. So we go over every element in the result at 3. And our result, if you remember, is, well, where did it go? Did I remove it? No, this is our result. Sorry, it was right in front of my eyes. So result at 3 gives us 1. So we go over every element in this array, it gives us 1, and push it into the final array. After that, we go to I is equal to 2 because we are going in reverse direction, right? And then we push in 2. Then we go here, but we can't go here because then we have a check that, hey, if k is equal to the length of final, and it is true, 2 is equal to 2, we break out and we return final, and there's our answer. So let's run it and hope we've not made any silly mistakes. And we have. The mistake that I've made is that I've done max. I told you I needed to do length. I can't do max because, you know, we are trying to do keys over here. I told you that if we do nums.values or something like that, you'll have to do a more complicated equation than that. Then you'll have the right answer. But we're just doing the length of nums plus 1. Accepted. Let's submit. And that is the solution. If you click on analyze complexity here, it will say O of n because it is indeed O of n. The reason for that is this is O of n. We go through every element in the mapping. This is, I'm not sure what this is, but in the worst case, this would be O of n because there can be all unique elements. So mapping is all unique elements. So it would just be the same as the nums list. The number of elements in nums and number of elements in result will be the same if both of them have unique elements. Then in the worst case, this is also O of n, and final is equal to this. Then what we're doing, and this is the most confusing part. Many people think that if it's a nested loop, it's always going to be O of n squared, but that's not how it's calculated. How we calculate this is that we go from the end of the array to the beginning of the array. And what we're trying to do is just break out as soon as we find k elements, right? So the whole purpose here is finding top k elements. So the time complexity here is just going to be O of k. And k is definitely, like, if you can see, it's not a very big number. It's just the number of unique elements. So it can be O like 1000, but it's always going to be less than nums, right? Because it's always going to be the number of unique elements in the array. So it can be less than or equal to n. So in the worst case, this is also O of n. But in the average case, let's just say it is O of k, where k is the average target value, or the average most frequent elements. So the entire thing makes it O of n on average. And this is much better than the heap solution, which would be O of n log n, or some other sorted solution, which would also be O of n log n. And yeah, so this is the solution. The space complexity, by the way, is going to be O of n as well. We have a dictionary being used. In the worst case, as I said, everything is going to be the numbers that are present here, and the mapping here is going to have the same length if it's unique. So yeah, that's the space complexity O of n. Even this makes it O of n. So yeah, that's the solution.